Welcome. I'm glad to see you guys. Actually, I can't really see you, but I understand Disney on Ice is in town, so I commend you on making a good choice with your evening. So my name is Whitney Hunter. I'm a senior developer at Bodybuilding.com, and I would like to just share with you a little bit about a project that we wrapped up recently, and that was building an upload service using Amazon's technology, specifically the Lambda system. So when we started the project, we had a few goals in mind. We had a legacy upload system that had been in production for a while, but it had a few issues, specifically around scalability. And the goals that we had were to provide an easy-to-use API for all of our clients. We have a few different types of clients. We have a web client. We have various mobile devices. And who knows what will come in the future. So we wanted to set our foundation well for the future. And part of that was moving away from what we had, which was a kind of a monolithic architecture. And we wanted to move to a microservices design so that we would get some of the benefits of that, specifically being able to scale more flexibly without kind of scaling up the whole system. I'll talk about a little bit more about that in a bit. We wanted to make our services RESTful using the RESTful pattern. And one of the things that we wanted to do is make sure that clients didn't have to make assumptions about the server. And so we wanted to use Helios, which I will talk about shortly as well. And then we're, as a company, we're moving a lot of our services out to the cloud, specifically Amazon. And so a lot of Amazon's tooling made sense, and Lambda seemed like a really good fit for this project. And so in doing that, we were able to not only improve our scalability, improve the way that the system functions, but also reduce cost by using the Lambda technology. And then simplify management. As load changes, we don't want to have to be turning knobs and doing manual things to handle changes in load. So the big problem is that we do have changes in load when it comes to image upload. So I'm probably going to get arrested by the statistics police because this chart doesn't really have a y-axis, but you can see that there are points in time where we have a pretty large spike in traffic. We have these things called transformation challenges, where we encourage people to come to our site, sign up for a several-month program, and then we give away prizes at the end for people who transform themselves the most dramatically. And so the challenge requires people to kind of give us what they look like at the beginning and what they look like at the end. So those periods where people are uploading the starting images and the ending images, those tend to be those big spikes in the graph, where normally we get 4,000 to 6,000 images in a day. When we're doing the transformation challenge, start and end, we can get an order of magnitude more. So 78,000 images in a few days. And so that can be problematic. You know, our old system struggled during those times to keep up with the increase in load. So we definitely wanted to fix that. So let's talk a minute about microservices. So microservice architecture is a pattern, a strategy that's kind of been gaining traction over the last few years. I'm sure some of you have some understanding of what it is. But basically, microservices pattern is that you want to break up your system into small, discrete units, sort of focused around similar functions, use cases, so to speak. And then those discrete things are packaged into small units and deployed separately into separate processes. And so that allows for a lot more flexibility. Instead of having to scale out the whole stack, you can scale out these small pieces. So it's cost effective and it's more flexible. So generally, services are scaled horizontally across machines, and they're communicating through some lightweight mechanism, HTTP or a messaging protocol. And usually, a microservice will have its own data store. So they're kind of standalone things. And just to make it abundantly clear, this is kind of the microservices versus monolithic architecture. And so the diagram on the left is kind of what we're all used to. We build the services with all these functions in them. We put them in a WAR or an EAR file. We stick them out on some application server. And then the whole system is running. And if we need to scale, then we take the whole stack and we put it on n different machines. And so with microservices, of course, you're much more fine-grained, and you can mix and match and scale each thing independently. So as we were approaching building our upload service, it was kind of a greenfield activity, so we got to choose our technology stack. So I just want to talk a little bit about what we chose. So we're kind of a Spring-centric shop. Our legacy systems are Spring-based, and so Spring Boot was a kind of a natural choice. How many of you have experience with Spring Boot? Okay, a few, yes. Well, if you are using Spring technology, Spring Boot's really a nice kind of no-brainer when it comes to microservices development. It's an opinionated Spring-based application that uses, it makes assumptions about what you want based on things it finds in your environment. It looks at your class path, and it says, hey, I see that you have some web jars on your class path. I think I'll put in a Tomcat server for you. And so it makes these choices for you that a lot of times are correct, but if they're not, then you can override them through configuration. And so you can create standalone Spring applications that are just Java applications. You can run them just with the Java command. And like I said, you can get an embedded container, Tomcat, Jetty, Undertow. Those are the three that are supported at the moment. They're really awesome for developer productivity because you can start and stop the server quickly. And a lot of times, as I said, it just makes the right choice for you. It's a nice fit for microservices. If you're using a container technology like Docker, it fits really well in there as well. So part of our application architecture is, like I said, a RESTful application interface. And we use Spring MVC as our technology to implement that. And so it works well, again, in a Spring environment, but it's kind of one of many different REST technologies out there, but it's worked well for us. Spring also has a project called Spring Helios. So Helios, for those of you who aren't really familiar, it stands for Hypermedia as the engine of application state. That's clear, isn't it? I can just move on. Basically what that means is that your API provides you more than just the data. It also provides you with a set of controls or links that you can use to interact with the API. So I have this little example here at the bottom. Let's just assume that you have an API that returns customers, and it's a really simple API, and so it's just returning first name of Alice. But in some cases, you need to know more about Alice. Most cases you don't, so it's fine to just return the first name. But in the cases where you do need to know more, this is the URL that you would go to get more information. So the nice thing about it is it decouples the state transitions in your application from the client. The server can then be free to change those URLs because the client's not making assumptions about where it needs to go to accomplish some function. So we also used Hystrix. It implements the circuit breaker pattern. I'm not going to really say too much about that. If you want to know more, you should check out our tech blog and look at Ryan Deering's talk that he did on that. And then we use 3 different Amazon technologies. Amazon S3 is their storage service. Basically, it's kind of like a file system in the cloud. You can create namespaces, which it calls buckets. And then within each bucket, there is basically a file system. And so instead of a path, they call that a key to find an object within a bucket. It has a RESTful interface that you can use to put things in and take things out. But in most languages, you don't have to deal with that because Amazon provides an SDK that you can make calls to. And it will do the calls to the REST interface for you. And so it's pretty simple, buckets with files in it. Secondly, we use Elastic Beanstalk. Our RESTful application runs on Tomcat. As I said, it's a Spring Boot application. And we run those in Amazon EC2. Elastic Beanstalk is just an easy way to get applications into EC2. So it supports a number of different platforms. We use Java. We use Tomcat. And so you can easily deploy your application into Elastic Beanstalk. And it does things like scale to some number of machines based on some criteria that you set. And then finally, AWS Lambda. So Lambda is, you can think about Lambda as it's a function that lives in the cloud. And it runs in response to some event that happens. So they're stateless and transient, meaning if there's no event, there's nothing running. But as soon as an event gets sent to the Lambda, then the Amazon infrastructure fires up one of these instances and presents the event to the Lambda, processes it, returns whatever result is needed, and then it shuts it all down. So you can think of it as sort of this infinite resource of compute power. Of course, it's not infinite. I think by default, you're limited to 100 instances. But that's configurable, and you can increase. I don't honestly know what the absolute limit is, but you can think of it as just a function that you get in response to an event. And so the nice thing about it is, as I said, it only runs when it gets an event, meaning if you have low load, you have only a few of them running. If you have high load, you have a bunch of them, and you only pay for the time that you use when it's running. And they bill in 100 millisecond buckets. So that makes it fairly cost effective as well. And it's easy to configure. You configure only 2 things. You configure how much memory each instance of your Lambda gets, up to 1.5 gigs. And you configure how long it will wait around before it times out and gives you an error. Currently, there's 3 different technologies that it supports. It supports JavaScript as a Node.js function, Java 8, and PHP 2.7. And fortunately for us, it also bundles ImageMagick into each instance of the Lambda. So it made it kind of a perfect fit for our image processing. So at a high level, this is what our new uploader service looks like. We have Elastic Beanstalk on the front with a number of EC2 instances running Tomcat, and this hosts the RESTful application. And of course, it's fronted by a load balancer, but this is kind of the simple view of things. And it's communicating, pushing things into Amazon S3, and then it's also sending events to our Lambda functions to do processing on those images once they're either when they're uploaded or on a download request. We have actually both of those things. And it is a microservice. It's fairly straightforward and simple. There's really only 5 endpoints, 4 of which relate to upload, and 1 relates to download. So pretty straightforward. You can upload images from several different places, from your local file system, from some URL out on the web, and then we have cropped versions, and then download. So there's 2 basic system flows. You can probably guess one is for upload and one is for download. This is the upload flow. And so basically, a browser or a client of some sort has an image that it wants to upload, and so it makes a post to our REST endpoint, one of those upload endpoints we just saw, which runs in a Tomcat instance, and it will receive that image, and it will put it into an S3 bucket, and then it will send an event to Lambda, and then Lambda will start up, and it will grab the image out of S3 and do some processing on it. Now, in the case of upload, the processing that it's doing is 2 things. One, we want all our images to be converted to JPEG. So you can upload a PNG or a GIF, but they get converted to JPEG. The second thing we do is we strip all the EXIF data from the image so that you can't be tracked from our site. So that's pretty much it. Image comes in, gets put into S3, processed, and then the processed image gets put back into S3. The download flow is slightly more complicated, but not too much more so. Here, somebody is asking for an image, and we want to be able to provide different sizes of the image. So when you upload an image, of course, you upload an image at a certain resolution, but we have needs for that image to be at different sizes. So a client can ask for an image at whatever, well, it's limited to a certain set of images, but theoretically, it could be any image size. And so that, it goes through CloudFront, which is Amazon's CDN, but assuming it doesn't find it there, it gets back to our RESTful application in Tomcat. And the first thing it does is it checks the resize bucket. We have 2 different buckets. We have a original bucket where the upload put it, and then we have a bucket where we put resized images in. So it checks there first to see, have we processed this image before? And if so, it grabs it and returns it. If not, it will invoke the Lambda to do the resize operation, which then pulls the image out of the originals bucket and resizes it to the requested size, puts it into the resize bucket, and then control goes back to Tomcat, which pulls that resized image out and sends it back to the client. So let's talk a little bit more in depth about the Lambda piece, since that's kind of the interesting part. So this is the way that we did it before, right? So we had some number of machines, and we had an image store, and we were processing images in these constantly running processes. And so the question, of course, is how many machines do you need? And if you get it wrong, then you're either spending money on resources that you're not using, or you don't have enough resources, and your machine, or your process is probably going to fall over. So Lambda, on the other hand, as I've been sharing so far, is you get an event, the Lambda starts up and does whatever it needs to do, and then shuts down, and you can have as many of those running as you need. So what is a Lambda event? So an event is basically a JSON object that gets presented to the Lambda instance. Amazon has a number of predefined event types. So you can, for example, say, when somebody puts an object into an S3 bucket, I'd like to know about it. And S3 and the Amazon infrastructure will send you one of their predefined events. And there's a bunch of them. You can read the list here. I'm sure that's not all of them. But you can also create your own custom event type, which is what we did. And so this little example here on the bottom, that's the event type we use for image upload. It's It's simple. It just tells you, what bucket do we want to put it in, what's the key, and what type of image are we dealing with. So when it gets to the Lambda instance itself, it will be bound into some object of the platform that you're using. So in our case, we're doing the Java implementation. And so this is kind of the simplest Java implementation. There's an interface called request handler that Amazon provides that you have to implement. And it's typed by the type of the event and the type of the object that you're going to return. And then there's a single method that you have to override called handle request. Of course, it takes the type that you are going to pass in, plus Amazon will give you a context object, which you can use to find out some information about the environment that you're running in. And then you do something with that information, and you return something from the process that you did. And then so below you have that's the type. It's kind of a simplified version of that S3 image event, which basically corresponds to that JSON that I showed you a second ago. And so Amazon will marshal into that object for you and present it to your request, handle request method. So let's go ahead and take a look at a little of the code, and I'll try to demo. Oh, that's not what I was trying to do. OK. All right, so before we get into the Lambda stuff, my little sales pitch for Spring Boot is this is the class that implements the Spring Boot application. It's really quite simple. That's the whole thing you see on the screen. And there's actually more here than you really need. It's basically, it has a main method, so you can run it. And you call the Spring application run with your class and the arguments that came in. And then all the Spring niceness comes in. You get class path scanning. You get so it'll find all of our RESTful endpoints and fire them up. So, all right. This is our implementation of request handler. So this is our Lambda implementation. And so you can see here we have handle request. It's basically what I just showed you. And the implementation does three things. It gets the image from S3, converts it to JPEG, and then strips the EXIF data. And so each of those things, we use the command pattern. So each of those is a command that gets executed. And I'll just show you one of them real quick. So this is the one that converts to JPEG. And JPEG type conversion command. And that's a little hard to see, but basically what it does is it generates a shell command. Because what we're going to do in this base class is we call runtime exec, and we basically fork a new process to call image magic to do the processing for us. So, all right, let's go ahead then. I'm going to do a demo. Let's see if we can get the image, get an image uploaded. So before I start, so this is the S3 control for in Amazon. And you'll notice here I have two different buckets, one called Tech Talk Originals and one called Tech Talk Resized. And as it stands right now, they both should be empty. And so then I'm going to come over to the Lambda page. These are the two Lambdas that I've been talking about. One does the stripping and conversion, and the other does the resizing. I was going to do a live deployment of a Lambda, but it seems that the network here is not quite up to that. So it's pretty straightforward. I'll just walk through everything except for the actual deploy. So if you create a new Lambda, Amazon has a number of different blueprints you can choose, but we're going to just skip those. And a Lambda has a name. So in this case, doesn't really matter because I'm not going to do it. And you can choose one of those technologies. For Java, I choose that. You choose the package you want to upload. It's a jar file with all the dependencies packed in it. And then you have to give it a handler, and that's basically the class it's going to send the event to. And let's see if I have that still. All right, so it's just a fully qualified path. And then you have to give it a role so that it has the privileges to write to things that it needs to. And so that's that role. That's pretty much it. As I said, the only things that you can configure are the memory and the timeout. And that's it. So next says, this is what you're doing. Do you really want to create the function? I'm not going to do it because it won't work. But as you can see, pretty simple and straightforward. Let's go ahead and try running it, see if we can upload an image. So I have a postman here that is pointed to my local machine. And so before I run it, what I need to do is start up the RESTful piece. And as I said, this would normally run out on EC2, but just to show you how easy it is to run Spring Boot, I'm running the Spring application using a Maven plugin. And so you can just go ahead and start it up. And it should take about 15 seconds, except it's downloading a bunch of stuff now. All right, hold on. All right, try that again. So now it should take about 15 seconds to start up. And there we go. It started. All right. So now what we're going to do is we're going to post an image to that server, and it's going to throw it up. It's going to do the stripping and image conversion and put it into the S3 bucket. So I'm going to choose a file. I have this really awesome Bodybuilding.com logo that is, as you can see, it's a PNG, and it's 300 by 300. All right, so go ahead and send. And it's a little slow because of the network. Normally in the S3 data, in the Amazon data center, this would be much, much quicker. But hopefully it won't time out. OK, good, it didn't. And so we get a success, and we get some links. So this self link is a link to the image that just got uploaded. So let's just try that to make just as a sanity check. And so there's our image. And just to make sure I have nothing up my sleeves, let's look at this. So now we have a gallery photo, and here's the image. And I can download it. And there it is. OK, so we got an image into S3. And so normally, one of the flows that we do is we upload the image. And you'll notice that it's now a JPEG. So it got converted. And the EXIF got stripped. You'll have to trust me on that, because I can't prove that to you right now. But usually what we'll do is it gets uploaded, and then the client will download it again and do cropping. So I'm going to just upload it one more time as a cropped image. I'm not actually going to crop it, but assuming that the client had done the cropping, you would I have to steal this real fast. Okay, so so now I'll send it to the cropped. All right, there we go. So now we get the cropped version uploaded. And then now the last step is we want to get a resized version of it. And so we would just do a get on the image download endpoint. And this is where you'll notice, if you're paying attention, that I'm a bit of a liar, because the link that we got back from the upload had everything except for this last piece. That's the size we want the image returned in. We could make links for all the image sizes. We just haven't. But anyway, so this is saying we want to get the image, and we want it to be 200 by 200. And hopefully, if I set that up right, it's going to process it and resize it. And there's the resized version. So that is pretty much that. So with that, I'll be quiet unless anybody has any questions they'd like to ask. Yeah?
Have you hit situations where the limit of 100 lambdas is a problem, or can you tell how many lambdas you have going at any given time?
We actually aren't fully in production. So the answer to your first question is no, we haven't run into that issue yet. And I don't honestly know if you can tell how many lambdas you have running at any given time. Daryl, do you know if you can do that? Yeah. That's a good question. I don't know the answer to that question, I'm afraid. Anything else? Yeah?
So I'm curious what the overhead is as far as how long it takes to fire up the lambda. How long does that take to process?
Yeah. So a lot of the time it takes for the Lambda to run depends on the size of the image. It's dominated by the image magic processing, but just anecdotally in watching how long it takes an image that's not terribly large, maybe like a 100K image, it's in the few hundred millisecond range for it to start and run and stop. So I've noticed that the first time it takes a little longer. I'm assuming that Amazon does some stuff like keeping some of them hot for you so that it doesn't have to fire up the whole thing each time. But that's kind of behind the covers. I don't know that that's true or not. But we haven't done, at least to my knowledge, we haven't done a formal performance test. That's still something we need to do. But it's somewhere in the couple hundred, 200-300 millisecond range. Yep.
How did you debug the Lambda functions when you wrote them?
Well, that's a good question, because you can run them outside of the Lambda structure. I mean, it's just a Java function, so you can create a test harness and run them that way. I tended not to. I tended to deploy them and then run and look at the logs. These are all tied in with Amazon's CloudWatch. So you can, each run of the Lambda, there's a log that you can go look at. So I would tend to, run the Lambda, go look at the log and see. I mean, it probably would be less ideal if you had a really large, complicated function, but from the development I did, it worked relatively well. Yeah.
How do you know if your lambdas are failing? So as you go forward,
Yep.
you have to debug via logs.
Yeah. So you do get an exception back if there's an error. You'll get an error message back from the Lambda, which I sort of forget the details. I mean, it packages it up into a JSON response object that then your client can look at. Yeah. Yep.
I noticed that it looked like in your diagram, you're blocking that whole REST request.
Yep.
For that Lambda process. Is there any kind of like queuing or retry logic that can be done with Lambda, where if the first
first one throws an exception that you could have it automatically retry within that same REST request, or is that something that you would have either the client or the calling server to your REST request try again? How does that?
Yeah, I mean, you certainly could. You certainly could put in some fault tolerance. I'm not aware of any any tools that are provided by Amazon. You might have to design that yourself in the the REST layer. We didn't do that. We were happy with failures just being failures, and the user could retry.
Okay.
Yeah. Anything else? Yeah.
So, if you write a Lambda, if you need access to external resources, like you need to have access to the database, or you need to have dependencies with other web services, will that fit a Lambda pattern?
So you're asking if you need to have access to external resources, can you do that from a Lambda?
Right. Would that be a good idea for the users of a Lambda? Seems like right now you are just using it as a function, doesn't have any dependencies, so it's completely autonomous. And is that the real usage of a Lambda?
So you can access external resources. So the only external resource that we are accessing is S3. And so we just had to set up the policy to allow the Lambda to access our S3 bucket. But I'm sure that you could set it up so it could access Amazon's database technology or their event queuing system. I think that would just be a matter of getting your policy correct and then making the appropriate call. The only thing you'd have to keep in mind is whatever you're doing, you have to make sure it completes in the timeout period. So if you're doing something long running that's going to go longer than 15 seconds, or I mean, you can set the timeout for as long as you want, but you just have to make sure that you don't time out while you're doing whatever it is you want to do. Does that answer the question, or were you thinking something else?
More questions over here?
Okay.
So I'm not a Java developer. Boo, I know, I'm sorry. But I do have a question, and maybe it's obvious. When you are building your files that you then need to upload, how do you deal with configurations differences? I assume you've got some sort of a test or QA environment as well as your production environment. And then also extended onto that question, it looked like a lot of what you were doing was very manual, going to the website, uploading it into Amazon. Yeah. Is there a way to do that in some sort of automated approach off of like a build server or something of that nature? Yeah. So that's not all manually driven deployment.
Right. Yeah. So in reverse order. So I'm sure you can automate the process. We use Terraform as a way to automate a lot of our deployment to Amazon, and I'm pretty confident that you can deploy Lambdas through your CI system or whatever you'd like automatically. And in terms of different environments, we used Spring profiles. I mean, it's just a way of telling Spring to use different sets of configurations based on how you run the server. So we have a development profile, a staging profile, a QA profile, production profile. So that's kind of typical what you might expect in terms of having different configuration for each. But that's not really specific to any of Amazon's technology. That's more something we get from Spring.
Thank you.
Sure.
Any more questions? No?
All right.